Hello everyone, we are Team Hydra. Welcome to the demonstration of our project CoralWatch. This is a web-based application designed to monitor, analyze and detect coral health and ocean marine debris using AI-based insight. Let me walk you all through CoralWatch. So first, home page. This is a home page. Here user get a quick overview of what CoralWatch does. You can see the project name, a short tagline, and navigation links to other sections like coral health, detect debris, and why coral matters. Now, what are coral reef? Coral reef are often called the rainforest of the sea. They support nearly 25% of all marine life, protect coastal regions from erosion, and sustain livelihoods of millions of people through tourism and fishing. So, types of corals: hard corals, soft corals, and table corals. So, in this section, we have discussed why the coral reef matter, why we must save coral reef, and the urgent need for action. So, currently, detection of coral health and debris relies heavily on manual surveys and diver observations. This approach has several issues. First is it is time consuming and expensive. Then it covers only small regions at a time, and results are often subjective and inaccurate. So there is a limited real-time monitoring capability. So these are the three main reasons behind the bleaching of the corals. First is ocean warming, second is ocean acidification, and third is marine pollution. So we will discuss this section in a while. So this is a coral bleaching heat stress map. We can see that this is a heat map which is scaled from 0 to 20, showing the coral reef stress levels worldwide. Now let's move towards the another section, which is coral health check. So in this section we are identifying the coral health. So here we can see that there is a table which is distinguishing healthy coral and unhealthy coral. So these are the signs of healthy corals and these are the signs of unhealthy corals. And it is demonstrated using an example. So here we can upload the image and see the health of the coral. So when we click on choose file, let me select the image. So when we select the image and when we click on analyze health, it is analyzing the coral health. So we can see that it has created a bounding box around the coral and predicted the coral is healthy, and the confidence score of the model is 100%. Let's try with another image. It is analyzing. Again we can see that it has detected the coral, and this time the confidence score is 100%. So we are analyzing the health of the coral using a dual model approach. So first we have used a YOLO V11 model for the coral detection. Then after the coral detection, we are cropping the image, we are cropping the bounding boxes using their coordinates and resizing that bounding boxes into 128 into 128 pixel and feeding that image to the classification model, which we have used the ResNet model for the classification. Then it classifies whether the coral is bleached or healthy. So these are the scores of the YOLO V11 model, and these are the matrices of the ResNet 50 model. Let's move towards another section, which is detect debris. So in this section we will detect the debris, marine debris. So this is impact of the marine debris on the coral health. So now first we will choose the image, upload the image, detect debris. So we can see that it has perfectly identified and detected the debris, and the confidence score is 57.3. Let's try with another image. Again, it has identified the image correctly. So for the debris detection, we have used YOLO V11 model, and these are the matrices of the model. So the last section of our UI, which is our model section. So in this section, we have defined all our model pipelines and technology stack which we have used. So first we have used two YOLO V11 model, one for object, one for coral detection, and one for debris detection, because it has a real-time detection with high accuracy. Second is CNN plus LSTM plus ResNet 50. So it is a very advanced classification model which is used to classify healthy or bleached coral. And third, which is the main part, we have deployed all the models on the Hugging Face cloud. So rather than running all the models on our system, we have deployed the models on the cloud. So we can also use our UI on the mobile devices also. And this is a pipeline of our coral health detection. So first we are detecting the corals from the image using YOLO V11. Then after detecting, we crop the detected corals using the coordinates of the bounding boxes and resize them into 128 into 128 pixel, because it is a standardized input for our classification model. And third step is classification using ResNet model. So we feed that cropped images to the ResNet model and it classify whether the coral is healthy or bleached, because ResNet is very fine grained for image classification. Third is this is our development pipeline: data collection, annotation, model training, optimization, deployment, and continuous learning. And this is our marine debris detection pipeline. First is image upload, then YOLO V11 debris detection, bounding box creation, result analysis. So that's it. This is our UI. So let's take an overview at our Hugging Face cloud. So first, in this space we have deployed the YOLO V11 model for coral detection. We can see all the files, and also this space is live, the API is live. Second, this is a coral health classification space. Here the ResNet model is deployed and we can see API is live. Third is in this space we have defined the pipeline of our coral health classification, like the resizing and the cropping of the image. Again, it is live. Fourth is debris detection model. It is again the YOLO V11 model and it is also live. So let's conclude. So we have completed walkthrough of the CoralWatch web application. To summarize, I would say we have overcome all the challenges, resulting in a web application which helps with better detection and precise classification of corals and debris. And the link of the UI is in the description of the video. Thank you for watching this demonstration.